Howdy everybody, Steve here, KM9G. This is going to be another power station review video, but before you click away, this one has a car jump starter in it, and I'm going to see if we can use that for ham radio. We're going to put it through its paces as a power station, of course, to make sure that it does all the power station type stuff. And this one actually is more than a power station, it's a solar generator, which doesn't mean it generates sunshine, just like your gasoline power generators don't generate gasoline. This one takes sunshine through the solar panels that are in this box and charges the battery up that's in this box and then turns it into electricity for you to use, whether you have sunlight or not. Let's see a gas-powered generator do that for you. When you turn them things off, they're off. When you take the sunlight away from this, it still has power in it. Let's see what's in the box. Here is, holy moly, that's in there tight. Maybe we have to start with part 2 instead. Here is the box of goodies that you get with it. Instruction manual, we don't need that. Car charger, wall charger, and it's got that weird plug on it. So you're gonna need to keep this one's wall charger. And then so you have the thing that the wall charger plugs into, which is now external from the battery bank, which I guess helps keep the size down a little bit smaller. Ah, that's why it was hard to get out. There we go. Right there is the solar panel. That's a pretty slick little solar panel. I like that. So it puts out straight to the barrel connector, not to any of your MC4s, but we're hams. We can adapt that to make it do our thing. It's a 4-panel foldable. So not a lot of wattage, but probably enough to get the job done. But here is the battery pack, and behind it is this thing here. And this is actually something that I am interested in. I don't know what we're gonna get out of this, but I wanna see, because that's just a positive and negative connection there. There's no special intelligence here. There might be some special intelligence in here, but this part here is actually meant to jumpstart the car, which means we're gonna get more power out of it than usual. Quick walk around the front panel. We have the solar or DC in, which DC would also be your AC charging port. We have 118 watts worth of USB, 18 watts to USB-B, and it's orange, which should indicate quick charging, and 18 watts is probably quick charging. We'll test it out. 35 watts USB-C, 65 watts USB-C. I would like to see these both be the same wattage, but you know how that works. We have two 5525, maybe 5521 power connectors here. I'm not sure which one that is. We've got our 12-volt car port. We have a normal and an eco mode. And we have two AC ports. One of them has a hole for the ground to go into. The other one does not. But you ain't getting any grounding out of this thing anyway, because it ain't attached to the ground. It's pretty small and compact. I like it. It's, you know, hand size. It is the C400, so we'll have to see. Oh, it's got UD turbo too. Yep, see, there's the 400. You know I wasn't lying to you. What does it say on the bottom? 256 watt hours, 20 amp hours at 12.8 volts. So 20 amp hour, 12 volt battery, perfect. Let's see, the DC 7909 is 8.5 amps, and this is 24 volts out, 4 amps. So that gives you a hint at that DC input. But here's the stuff that we care about. The car cigarette lighter output is 12 to 13.6 volts at 10 amps. So that'll power your G90 QRP radio. And this is good QRP radio G90 size. If it was built this way, it would just sit right on top of the G90. I mean, you can still do that, but then you can't see the pretty display. AC output, 120 volts. There it is, that's where the 400 comes from. 60 hertz, 400 watts, 800 watts max, pure sine wave. So that's where the 400 comes from in the product name. It'll do 400 watts of AC output. USB-A ports, USB-C ports, 5 volts, 3 amps, 9 volts, 2 amps, 18 watts for the A port, 5 volts, 3 amps, 9 volts, 3 amps, 12 volts, 3 amps. So QRP radios right off of the USB-C port, but it's got the DC ports. 15 volts, 3 amps. 20 volts, 3.25 amps, PPS, 3.3 to 21 volts at 3 amps, and a total of 100 watts out of the USB-C port. So I don't know how they're gonna get 100 watts out of a 65 watt rated port, but that's okay. And people ask what kind of batteries are in here. This has got lithium iron phosphate batteries, LFP, which is such an easier way than typing in LIFEP04 with all the camel case and everything. But we need to get this thing charged up and we need to test it out. So I'm gonna plug in the solar panel since I have it sitting right here. Solar panel has a 1-wrap tie on it to make it easy to get that stored up and not lose the 1-wrap. Nice long cord so we can get it over where the sun is. Let's plug that in and open up this port. And it immediately springs to life on the display. It comes 71% 100% charged. At its current output of 0 watts, it will last 99.9 hours, which is full scale. That's as high as that scale goes. It's just gonna last forever because we're not technically using it. We have lights on the front. They're hard to see in the daylight, but there you go. 4 watts of output to get the lights to work. And then they just went off. Okay, cool. So now the lights are off. The lights are on. Low, medium, high. I'm not showing any indication on charging. Let's see if it looks different if I plug it into the wall. Our wall charger also comes with the 1 wrap. Let's move this over here to where I have my wall plug plugged in. Okay, now we show 0 watts input, 3 watts input, 12 watts input. She's ramping up. We did not see that with the solar panels. And it says it's gonna take me about an hour to fully charge this thing up. 93 watts of input. The power supply says 24 volts, so we take 24 volts times 4 amps. We get 96 watts. And if we look over here at the display, it says 93 watts of input, so it's getting pretty close. And the more full the battery gets, the harder it is to put power into it. So we might already be at that stage where it's a little harder to push power. In the meantime, I wanna get out my multimeter and test to see what's going on with that solar panel. Could be anything, or nothing at all. Danger glasses on. I like this meter because it is small and simple and compact and easy. I'm gonna put it on to the 200 range. I'm gonna put it to DC volts, whip out my probes, grab the power connector from the solar panel. We're gonna assume center positive, so hold that on the outside. And this is one of those weird ones where you can see the pin inside, and then it's surrounded by metal, so we gotta just get the pin. And of course, 2 round things together. Yeah, no power from the solar panel. Interesting. Nothing at all. We're in some sun. Let's get in more sun. So you can see by my shadow that we have sunlight shining down on the panel. Let's get my shadow off of the panel. Meter in the grass. This is real electric work right now, boys. Nope, there goes the camera. Oh no, I did just get voltage. Just as the camera fell over, I saw 17 volts. Let's do it again. Nothing. Come on, I saw it work before. I think it's just shy. All right, I think I figured it out. See if we can get this on camera because it's all kinds of awkward down here on the grass. If I touch the inside of the barrel connector and not the pin, I was trying to touch the pin and the shield, 20.7 volts of power. Okay, so it was me, it was operator error. Let's get the meter out of the way and let's get the power station back. And we will look at the display there and it should say up here in the top corner what it's receiving. I'm plugging in the solar panel. Oh, there we go, it's working. 0 watts input. We're doing some maximum power point tracking stuff. 3 watts, 8 watts, 14 watts, 20 watts, 23. And of course, I'm not even pointing the camera at it. 26 watts. Let's tilt the panel a bit. 27 watts. So 27 watts, it's still gonna take 29 watts, got it up there. All right. 3.1 hours to charge off of the solar panel. And we're just full sun today. All right, that's 2 tests passed. Got to finish getting this thing charged up. All right, we're back on AC power from the outdoor outlet on the side of the RV. 95 watts of input, 0.8 hours of charging. I want to try, while we're sitting here waiting, I want to try this jump starter connection here. So I have my jumper cables. They only fit in one way, they're keyed, so let's put them in there. So it's a good strong connection. And then we're still gonna play with the meter a bit. All right, let's clamp this down here. We've got black to black, red to red, and we're putting out 13.5 volts. That looks good. I need to get this thing inside once it's charged up and put it on my load device and see how many amps we can pull out of this. Let's see, while we're waiting, overboost mode, UD turbo. Let's see what that is. That caught my eye. That wasn't what I was looking for. I was actually looking for the solar panel to see if it had any ratings on the solar panel. Eco mode. The time for the no operation screen to go out will be reduced from 1 minute to 30 seconds. When the AC-DC output port is turned on, it will intelligently shut down the output port if misused for 2 hours with no load. 5 hours for normal mode. I think when they say misused, they mean unused. The management chip will intelligently allocate energy to ensure that the product's standby power consumption is reduced to extremely low levels. Okay, so we definitely want to do eco mode as often as possible. And then we have Turbo. Okay, so that's the 800 watts. Without incurring operation failure due to overload protection when UD Turbo is lit up. Turned on by default, which will improve user experience and will not have any negative impact on the product. There is no need to turn it off. Okay, so it automatically does all that. Can the product power a CPAP? Yes, but please pay attention to the remaining power and the remaining usage time before use. Don't want you to go to sleep with your CPAP on and wake up with your CPAP off. Kind of defeats the whole purpose of a CPAP, trying to keep you asleep. Solar, 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 solar. It doesn't say anything at all about the solar panel. Okay. So this is actually one of the more fun things I like doing. I like sharing on the channel with you guys is getting interesting things to do things that are interesting. I guess it's getting ordinary things to do things that are interesting. So I have this radio set up so that I can test this thing out and see if we can use, let me just turn around and show you. I've got the power station here and I'm going to use the jumper cables that came with it. These should be able to provide higher than the 10 amps that you can get out of here. I don't know how much higher. I got no way of testing that. I have a Yaesu 857D radio. I have a power meter and it's all connected into a dummy load, so I don't need to worry about identifying or anything like that. The 857 is connected up to a set of jumper cable leads itself, so I need to find a safe way of not having those guys connected. If any of you guys are car buffs, then you know it's going to take 300 amps to assist a weak battery in jump starting your car. If your battery is completely dead and your car is in fantastic shape, maybe you'll be able to start the whole car with that. It's not going to provide 300 amps. It needs to be pulled from it. It's not going to be like instantaneously there's 300 amps there. There needs to be something going on. I already connected up my meter. That's fine. And I can actually do that again. I've got a clamp on meter, so I'll show you that real quick too. And that'll show that, you know, the meter is plugged into this thing and it's not providing 300 amps into my simple $15 meter. It's only providing a little tiny bit of amperage. So that'll show the safety of where we're going with the 857 part of the test. The 857 part of the test, it's a 100-watt radio. I'm going to key down on that thing and two things are going to happen, possibly. Number one, everything's going to work fine. This is going to be the most amazing thing on the planet. Or number two, the radio is going to gracefully shut down because it doesn't have enough current to produce the output. It's going to kind of quit and give up to save itself. And I have seen this on plenty of other radios, even on using benchtop power supplies, you know, a 30 amp bench power supply, and you try to key up on a 2-meter radio while you're trying to key up on a HF radio. There's not enough power there to run both of those transmitters simultaneously. They both just shut off. Same thing that happens when you turn your car off as you've got a mobile radio plugged in, and this is a mobile radio, so it should have all of the circuitry baked into it to do that. And if not, I'm coming after you, Yaesu. Let's get this test moving. All right, so we are rigged up for running. We have the regular voltmeter here pulling 13.2 volts out, good. We have our clamp-on amp meter showing negative 0.09 amps. So if this is all reading right, then it is going in the wrong direction. And that port on the back is energized whether the battery is on or not on. Because it's just a straight up DC port with no on-off thing going on there. So you can see that I'm not, you know, shoving 300 amps into this guy here. There aren't any specifications on the website as to how many amps this thing can put out from these cables back here, but we're going to try it and see what happens. If it's ugly and it works, then it ain't ugly. So I've got my alligator clips, which then terminate out into power poles for the radio, plugged in. I've got it clamped to the desk, so these guys aren't going to move. They're not going to interact with each other. They're not going to touch, and mostly because my alligator clips for my power pole leads are bare. These guys are all the ones that come with the power station. These guys are all shielded and covered and protected and whatnot. That's fine. I still have my voltmeter probes, 13.2 volts, and I have my amp meter clamped on at minus 0.09 amps, and she's sitting over there. There might be a little bit of contention with having the negative wire so close to the, that's not even the negative wire, that's the negative lead for the meter. That should be fine. Let me move that anyway. Okay, now that is moved, we have the positive wire going through the clamp meter, and we have the negative wire from our DC voltmeter plugged in here. I'm going to plug in the Anderson power poles, and I don't remember if I left this radio on last time or not. All right, we're plugged in. No magic smoke has come out. Interesting. We have power, we have everything going on there. Interesting. All right, I had to adjust the power pole connection in order to get the radio to come on. The radio is now on, and we're plugged into a 100 amp hour battery. So I need to get it recabled back now that I have verified that the radio is working. All right, we left it on, plug it in. It should just come right on. Yep, she's on. All right, let's look at our meters. 13.2 volts on the meter, and minus 0.89 amps being drawn. I wonder why that is showing negative, because that is showing positive. Anyway, the radio is up and running. So now let's find a good frequency. It's on FM. This frequency works. I'm going to take my microphone and I'm going to key down, and it's either going to shut off or it's going to work. That's pulling 12 amps to transmit 17 watts. My dummy load's not happy at all. Let's try that again. There we go, 100 watts, 1 to 1 SWR, and we've got 17.5 amps coming out of the power station, and 12.5 volts. The radio is happy. I like it. Key up and let it rip. I'm actually surprised this is only putting out 17 amps. Let's try it on a different band. All right, FM on 160 meters, 105 watts out, 17.8 amps drawn. I was actually really expecting this radio to pull more power out than 17 amps, but 17 amps is better than 10 amps and kind of proves that this thing is working. What do y'all think about that? I'm actually pretty shocked and impressed with this. This is the first small portable power station that will power a 100-watt radio directly. And we can make a better connector than this alligator cable nonsense, but proof of concept, success. Turn the radio off. And drawn right down. Nice. And the battery is still at 13.2. Let's check out some noise. This is what it looks like with no load, no nothing going on the AC side. And the AC inverter is off, but the DC power on the back side is on, and the radio is running. So I have this fan here that I'm going to turn on. This is plugged into regular wall power. So I'm going to see what kind of noise we get. This is with it on. And this is off, and I'm not seeing much of a difference there. And we're running about 900 megahertz of spectrum. So nothing really going on there. Let's re-plug this thing in. Okay, we've got AC plugged in. Turn on the AC power. You can see a little light there, and it says output in watts. Let's turn her on for the fan. 13 watts output, 12 watts output to run the fan. And here is your spectrum display. Again, no real noticeable change. Off and back on again. Off, on. I'm going to turn it on to heat mode and see what we can get, because I really need heat today. All right, the fan just kicked in the inverter. 400 watts of output, and the UD turbo is kicked in just to keep it at 400. So the fan on speed 1 is about 400. Let's turn this back off. I'm looking at this spike right here. I don't remember that one. Inverter's off, fan's off, spike's still there. So it was just my poor foggy memory. All right, let's turn this back on to low. And I'm going to turn off my DC load. Still looks clean. Let's get the screen back on here. 400 watts of output. I'm gonna turn this thing up to power level 2, which is gonna make this thing go into high power output mode or give up. Yeah, I think it's limited. I think it can't put out more than 400 for this fan. Yep, there's my error. So she tried, which is actually really good. She tried, she couldn't do it. The fan is a 1,000 watt heater fan type deal that you guys have seen, you know, all over the Walmarts and things. So I asked it to do more than it could have, and it safely, gracefully shut down. Pretty cool. I'm gonna do it one more time and see what actually does shut down. Inverter's back on, fan on low, fan on high. I saw it boost to 430, 500, 453, back down to 400, and she just shut off. And the DC load stayed on the whole time. Awesome. Turn that off. Turn that back on. Turn that back on. Runs good. She did the thing. Awesome. And no real noise on the noise meter. Let me turn this fan off here so we can not have the air noise. So it's pretty cool. There isn't really a standard test for noise. There's no real good way to do it. Short answer is we're hams. We can figure out what to do if there is noise. Move your antenna farther away. Install chokes on your power lines going from the power supply to the radio. Don't use the inverter if that's what's causing it. Whatever the case may be, but so far she's pretty quiet. I bet if I was to really hunt down where the noise is and zoom in the span on the Tiny SA, I'd be able to see something, but we're hunting. We're on a witch hunt at that point. This is good enough for what it's designed for, which would be like a good camping weekend. So enjoy your camping and don't worry about RFI. Get on the air, activate the park. Be a ham. Well, I can't say be a ham and don't be grumpy, can I? This should really go without saying, but I'm experimenting, I'm playing. There shouldn't be any reason why this doesn't work forever without any issues, but it's an experiment. So do it at your own risk. Cool power station. Weird use of a power station to power a 100-watt radio off the jump starter port. Might be a first here. Could also be a last. But all the rest of this stuff, power station's just fine. You know, legal mumbo jumbo stuff. Don't come after me if you try this thing and it doesn't work. Like, should work. Worked for me. Might not work for you. Not my fault if you try it and you screw up. Because I'm just showing you what I'm doing. Don't be like me. Sure. If you made it this far, I hope that means I provided some value to you. If so, hit that subscribe button down below, right below the video here, because I need subscribers and y'all can help. Can't subscribe to myself more than once, and I already have, so I need your help. If you want some more information on this power station, there will be links in the description down below for you. There will also be a bunch of other stuff. If you just want to run QRP off of this and not do anything crazy with the car jump starter part on the backside, then I have a USB-C PD trigger cable that'll run your QRP radio. I've got a car port. I had to think about what they wanted to call those things these days. I've got one of those car port to Anderson power pole connectors, so you can run your G90 at 20 watts off of the car port, which will put out 10 amps, which is all you need for the G90. If you want to run your 857, your 100-watt radio down at like 20 watts or so, looks like it's also going to work, because the 857, even though it says 22 amps draw in the manual, really only took 17 amps. Well, 18 for rounding. You want a little bit of overhead. That's probably what they were doing. They probably wanted a little overhead for it, but she did the thing. I like it. This is what we have been looking for. High output DC on one of these portable power stations. Batteries are awesome. Batteries with built-in solar charge controllers and the ability to hook up solar panels and AC inverters to power your fan if you want a fan, or maybe get a DC fan or whatever. These things are just like Swiss Army knives. They're awesome. And hams like awesome gadgets. If you want to know how long this battery will last for your activation, I have a video right over here that goes over all of those details and shows you how to figure all of that stuff out. Why don't you head on over there? I'll be waiting for you. Thanks for being awesome.